Hi, welcome to the 5th episode in these tutorials. Today we're going to talk about collision and collision detection. If you don't know what this means, stay tuned and you will find out. The first thing we're going to do is to detect the collision of the ball with the paddle. So to do just that, open up your editor, and this is the code from the previous lesson. So at the top we have to specify some things. The first thing we're going to do is specify the paddle width, and that's going to be 40. This is the width of the paddle picture in pixels, and the paddle height, and this is only 10. Save that. And the next thing we're going to do is to create a function. We will call that function ball collides with paddle, and I'm going to create it over here. I'm just going to say function ball collides with paddle, and the function over here. And in here I'm going to say something like this: if the ball Y position is greater than or equal to the paddle Y position minus paddle height, and the ball Y position is lower than or equal to paddle Y, and I'm going to put some braces over here. So this will basically tell if the ball is on top of the paddle, and the ball X position is greater than or equal to paddle X position minus paddle width divided by 2. So that's the half of the paddle width, and the ball X position is lower than or equal to the paddle X position plus paddle width divided by 2. Then, and this basically says if the ball is somewhere on the paddle, left or right. So if that's the case, we're going to return true, else we're going to return false, and end that over here. Now save that. So now we will have to use this function, and the perfect place for that is in our onUpdateFrame handler. So remember that this function will be called on every frame. So in here I'm going to say something like this: if the ball Y position is lower than or equal to 5, and what this means is if the ball is going off the screen in the upper part, or the ball collides with paddle, that's our own function over here, then we're going to flip the Y speed of the ball. So to do that I'm going to say minus ball Y speed and end that over here. So let's see the result. So as you can see, the ball hits the paddle. Now we're going to detect if the ball is hitting the wall or if the bow is going below the paddle. To do just that, we'll need something new. I'm going to show you where the config file for the Rapanui framework is, and as you can see in your imob Rapanui directory you have a file called config.lua. Drag it into your editor, and over here you can see that there are some configurations for the iPhone dimensions and for the iPad, and the current device that is selected is iPhone 3G. So to use that, we're going to close this, and at the top of our file we're going to say we will get actually the width and the height of the device over here. So window underscore width is going to be equal to the config.sizes, and in brackets I'm going to specify config.device. So this currently will point to our iPhone device, and I'm going to get the first element of that table, and the same here almost for the window height, config.sizes, and in square brackets config.device, and I'm going to get the second element. So now we have the width and the height of the device. So let's see how we're going to use them. Again, in the onUpdate frame handler, first we're going to detect the hitting the wall. So I'm going to specify bow.x is lower than or equal to 5. So if the bow is next to the left wall, or the bow.x is greater than or equal to window underscore width, then I'm going to end that here. Just as the y speed, we're going to flip the x speed. I'm going to say minus bow.x speed. And now we're going to detect if the bow is below the paddle, and we're going to reset it window. If the bow y position is greater than the window height, so if the bow is off the screen, we're going to call our function init bow again. Now I'm going to remove these brackets over here just for consistency. Save it and let's run it. Just a second. So again, the paddle is hitting the bow, and as you can see, now the bow hits the walls and the ceiling, and if we drop out the bow starts again. Now we are going to detect if the bow is actually hitting a brick. To do that, I'm going to specify some new constants over here, and I'm going to need brick width equal to 40 and brick height equal to 10. These values are the same as the paddle values. That's just because the images are of the same size. And down here I'm going to specify the bow width, which is 16, and the bow height, which is again 16. And in order to detect which brick is actually hit and be able to remove that brick from the table of bricks, I'm going to set the brick row equal to the current row in the init bricks function, and the brick column equal to the current column. Okay, and now just below the ball collides with paddle function, we will write a new function which we will call ball collides with brick, and it over here. And this will be a bit lengthy one, so stick with me. And we're going to iterate over all columns with a step of 1. Close that, and in here I'm going to say for each row again with a step 1, end it here, and I'm going to get the brick I have to specify a key of the concatenated row and column. Now I'm going to check if the brick is not new, and if it's not, I'm going to do something. If it is new, it means that it is already off the bricks table. So in here I'm going to say if ball y position plus ball height divided by 2 is greater than or equal to the brick y position minus brick height divided by 2, and ball y position minus ball height divided by 2 is lower than or equal to brick y position plus brick height divided by 2. And what this means is if the ball is somewhere on the height of the brick, and now we're going to detect if the ball is on the height of the brick and it is somewhere on the width of the brick. So we're going to just specify if the ball collides with the brick. And the next statement, and ball dot x position plus ball width divided by 2 is greater than or equal to brick x position minus brick width divided by 2, and ball dot x position minus ball width divided by 2 is lower than or equal to brick x position plus brick width divided by 2. So if .o is a true statement, then we're going to return true as a result and the actual brick. Okay, and end that over here. If none of that succeeds, the result of the function will be false, and as a brick we will return new. Okay, so we will have to use this function now, and you can go to your on update frame handler function, and just above the window height detection I'm going to create a local variable called collides with brick and the brick itself, and I'm going to call the function that we just created, bow collides with brick, and if collides is true, and that over here, I'm going to set the bricks. I'm going to remove the brick from the bricks table, and as a key I'm going to specify the row and the column of the brick. Okay, and that will be equal to new, and we are going to set the alpha property of the brick to 0. We're going to make it invisible on the screen, and we're going to flip again the y speed of the ball, and ball speed will be equal to ball minus ball y speed. So save that, and let's see what we have. Here is our Rapanui directory. Let's run the path file. And I'm hitting it. So as you can see, the brick is removed and the ball flips its y speed. That's it for this episode. We covered a lot of ground. The theme of collision detection is actually pretty big in game development, but for our simple game, it wasn't that hard, wasn't it? I'm going to upload this tutorial code in the GitHub repository as always. To get the links, you can go to makeyourown2dgame.com and look for the blog post about the 5th part of these videos. In the next episode, I'm going to talk about and actually show you how to upload your game to an Android emulator and run the game inside your emulator, or maybe you can even upload it to your own phone. See you then. Bye.